Have you ever felt like you're just drowning in information? Like you wish there was a shortcut to understanding powerful new concepts, maybe without wading through all the dense technical stuff?
Yeah, I think we all feel that sometimes.
We hear you. So today, we're cutting through that noise. We're doing a deep dive into Python. It's this programming language that's, well, it's really shaping our world.
Absolutely.
Our mission here is simple. Give you a clear, solid foundation. Why is Python so popular? And what can it actually do for you? Even if maybe you've never typed a line of code in your life.
That's right. And for this deep dive, we've really dug into a fantastic resource. It's a comprehensive course transcript, very beginner-friendly, called Python Full Course for Beginners 2025 from Programming with Mosh over on YouTube.
Yeah, he's great.
He is. So our goal isn't to, replicate the entire course that would take hours. Instead, we're distilling the absolute must-know starting points, the key practical takeaways. We want you to get that core knowledge without feeling totally overwhelmed.
Exactly. Consider this your essential jumpstart. We want to equip you with that fundamental grasp of Python's power, show you how to take those first practical steps, and introduce its core building blocks. It's really about delivering actionable knowledge, stuff you can actually use. All right, let's get into it. Let's unpack this. Why Python? Why on earth has it just exploded to become like the world's fastest growing and most popular programming language?
It's pretty amazing, isn't it?
It really is. And it's not just for the hardcore software developers anymore, right? We're seeing mathematicians, data analysts, scientists, accountants, network engineers, even kids using it. What's the magic formula here? What makes it so universally appealing?
Well, it really boils down to a few key things, and they often feed into each other. First off, it's the simplicity and efficiency.
Okay. Less code, right?
Yes, less code. But it's more than just that. The real insight, I think, is how Python's design almost forces clarity. It's clean. It's readable.
It's so easier for humans to understand, not just computers.
Precisely. Which makes it faster to write, sure. But crucially, way faster to understand and maintain down the road, even for big, complex projects. Mosh gives this great example. Just getting the first 3 characters of hello world. In C or JavaScript, it might take a few lines. In Python, it's just one simple, clear line. Print, hello world 0.3. Clean syntax.
Wow, okay. That's pretty direct.
Second big reason, it's a truly multi-purpose language. It's like a Swiss Army knife for coding.
So you can use it for lots of different things.
Exactly. Data analysis, AI, and machine learning, which are huge fields right now. Writing little automation scripts to make your life easier, building websites, mobile apps, even desktop apps. Yeah. Software testing, network stuff, even hacking, though ethically, we hope.
Right. So that versatility leads to jobs, I assume.
Oh, absolutely. That's the third point, career opportunities. Python skills are central to many high-paying, long-lasting careers, especially, like I said, in AI and machine learning. The source mentioned an Indeed.com stat from back in March 2018. Even then, the average salary for a Python developer in the U.S. was over $115,000.
Wow. That's a strong indicator.
Definitely. Fourth, it's what's called a high-level language.
High level. What does that mean in simple terms?
It basically means it simplifies things for the programmer. It handles a lot of the complex behind-the-scenes stuff automatically, like memory management, deciding where to store data in the computer's memory. In languages like C++A, you often have to manage that yourself, which, trust me, adds a lot of complexity. Python just takes care of it.
Okay, so it abstracts away the tricky bits. Nice.
Exactly. Fifth, it's cross-platform. You write your Python app once, and boom, it generally runs on Windows, Mac, and Linux without needing major changes.
That's huge for deployment.
It is. And finally, number 6, a huge community and ecosystem. Python's been around for over 20 years now.
So lots of people using it, lots of help available.
Tons. Chances are, if you run into a problem, someone else has already solved it and posted the answer somewhere online. Plus, there's this massive collection of pre-written code libraries, frameworks, tools that you can just plug into your projects. Saves a ton of time.
Okay, that ecosystem sounds like a massive advantage. And just quickly, you mentioned it's been around. What about Python 2 versus Python 3? Is that something beginners need to worry about?
Good question. The source rightly emphasizes Python 3. That's the present and the future. Python 2 is legacy now. Support officially ended back in 2020. So, yeah, everything we're talking about today applies to Python 3.
Perfect. So if someone's listening and thinking, okay, I'm sold, how do I start? Well, what's step 1?
Step 1 is downloading it. Head over to the official website, python.org. You'll see the latest version there. The course used 3.13 as an example. But don't worry if it's newer when you look. The basics we cover will still apply.
Okay, download from python.org. Any tips for the installation?
Yes, one crucial one, especially if you're on Windows. During installation, you'll see a checkbox probably near the bottom that says something like Add Python to Path. Check that box.
Check the box. Got it. Why is that so important?
It just makes it much easier to run Python from your computer's command line or terminal later on. Forgetting it can lead to some frustrating setup issues. So, yeah, check the box. Save yourself a headache.
Okay, check the box. It's installed. How do I know it worked?
Easy peasy. Open up your terminal. That's Command Prompt or PowerShell on Windows, Terminal on Mac or Linux. Then just type a command. On Windows, try Python version. On Mac or Linux, you might need Python 3 version.
And it should just tell me the version number.
Exactly. If you see something like Python 3.13.x or whatever version you installed, you're good to go.
All right, so Python's installed. Now what? What am I actually interacting with when I type Python?
You're interacting with the Python interpreter. Think of it like the engine that actually understands and runs your Python code.
Mm-hmm.
You can even type code directly into it, into what's called the interactive shell. It's great for quick tests.
Like a calculator.
Sort of, yeah. You can type 2 plus 2, hit enter, and it'll immediately spit out 4.
Cool.
Or you could type a comparison, like 2, 1. Hit enter. It'll say true. That's a Boolean value. Basically Python's way of saying yes.
Yeah.
If you typed 1, 2, it would say false or no.
True and false, got it. So it understands logic. What if I type something wrong? Like if I just type 2 and hit enter.
Ah, good question. It'll give you an error. Probably a syntax error.
Syntax error. Like bad grammar.
Exactly like bad grammar. Just like English has rules about sentence structure, Python has rules about code structure, its syntax. 2 is incomplete. It's expecting something after the seat. The interpreter is saying, I don't understand this sentence.
Okay, that makes sense. So the interactive shell is cool for quick tests, but you wouldn't write a whole application in there, right?
Right. For anything more substantial, you need a code editor or something called an integrated development environment, an IDE.
Code editor versus IDE. What's the difference?
Think of an IDE as a code editor on steroids. A basic code editor just lets you write and save text files. An IDE includes the editor, but adds lots of fancy features to help you out.
Like what kind of features?
Things like auto-completion. It suggests code as you type, which is a huge productivity boost. Debugging tools to help you find and fix errors. Testing features, stuff like that.
Okay, so what are the popular choices?
There are lots. For code editors, VS Code, Atom, and Sublime Text are really popular. For full-blown IDEs, PyCharm is probably the most popular one specifically for Python.
And the source material Mosh's course uses?
It uses VS Code, Visual Studio Code. It's free, it's made by Microsoft, and it runs everywhere. It's technically a code editor, but you can add extensions to turn it into a very powerful IDE.
Okay, VS Code. So I download that from .code.visualstudio.com.
Yep, that's the place. Once you have it installed, you typically start by creating a folder for your project, maybe call it Hello World or something. Then, inside VS Code, you create a new file within that folder. Let's call it app.py.
And pop.py. So all Python files end with .py.
That's the convention, yes. Tells everyone and the tools that it's a Python file. So now you've got your app.py file open in VS Code. You can start writing actual Python code. And probably the very first thing you'll learn is the print function.
Print. Okay, what does that do?
It's a built-in function. Think of it like one of the standard buttons on a TV remote, always there, ready to use. Its job is to display things on the screen in your terminal output.
How do I use it?
You just type print, then opening and closing parentheses. Inside the parentheses, you put what you want to print. If it's text, you need to put it inside quotes.
Single or double quotes?
Either works. Python's flexible.
So print hello world or print hello world will both display hello world when you run the code.
Okay, print hello world. Standard first program. Now, here's where it gets interesting. You showed this earlier.
Yeah.
What about that example? Print. What's happening there?
Ah, yeah, that's a neat little Python trick. It basically tells Python, take the string and repeat it 10 times. So when you run that line...
I see hint. 10 stars in a row. Exactly. It's handy for drawing simple dividers or shapes sometimes. But more fundamentally, if you had, say, print hello world on the line before it, Python runs them in order, top to bottom. First hello world, then the stars.
Instructions execute sequentially. Makes sense. Okay, so VS Code is our editor. You mentioned turning it into an IDE with extensions.
Yes. To really unlock its power for Python, you'll want to install the official Python expansion published by Microsoft itself. You just search for Python in the extensions view within VS Code and install the one from Microsoft.
And what does that extension give me?
A whole bunch of useful stuff. It gives you linting, which is like having a grammar checker for your code. It analyzes your code as you type and flags potential errors or style issues.
Okay, catches mistakes early. Good.
Yep. It adds debugging tools, which are essential for figuring out why your code isn't working the way you expect. It provides IntelliSense or auto-completion, suggesting code completions to speed things up. It helps with code formatting to keep your code neat and readable. It integrates with unit testing frameworks and provides code snippets for commonly used blocks of code. It really transforms VS Code.
Wow, okay. That sounds incredibly helpful. Can you show how that linting thing works? Like, how does it actually point out an error?
Sure. So once the extension is installed, it often uses a tool called Pylint by default. Let's say you accidentally write print hello without the parentheses. That was valid in Python 2, but it's an error in Python 3.
Right, Python 3 needs the parentheses.
Exactly. So the linter would almost immediately put a little red squiggly underline under print. If you hover over it, a tooltip would pop up saying something like missing parentheses and call to print.
Ah, okay. It tells you exactly what's wrong.
Yep. Or remember our 2 syntax error. If you typed 2+ and just left it hanging, the linter would flag that too, probably saying invalid syntax. Mm-hmm. You'll also see a list of these issues in the Problems panel in VS Code. You can even choose different linters if you prefer, using the command palette, usually Ctrl plus Shift plus P or CMD plus Shift plus P, and searching for select linter.
So what does this all mean for writing clean code? You mentioned formatting.
Right. This ties into something called PP8. It stands for Python Enhancement Proposal 8, but really it's the official style guide for Python code. It gives recommendations on things like indentation, use for spaces, line length, how to name variables, where to put spaces around operators, things like that.
Like a rule book for making code look consistent.
Exactly. It makes code much easier for everyone to read and understand if it follows a common style.
But do I have to remember all those rules?
Well, you should learn the basics, but the good news is tools can help. The Python extension often includes or helps you install formatters like AutoPep8 or Black. These tools can automatically reformat your code to comply with PP8.
Automatically? How?
Let's say you write x equals 1 without spaces around the equal sign. PEP8 says there should be spaces, like x or 1, or maybe you have multiple variable assignments that aren't lined up nicely. You can just right-click in your file and choose Format Document, or even better.
Yes.
You can set VS Code to format your code automatically every time you save the file. There's a setting called Editor, Format on Save. Turn that on, and boom, clean PEP8 compliant code every time you hit save. It's fantastic.
Format on save, definitely enabling that. Okay, so we write code in VS Code. It helps us find errors and format it. How do we actually run the code we wrote in app.py?
Several ways. You already know you can run Python in the terminal. You could navigate to your project folder in the terminal and type python app.py or python3 app.py.
Okay, run it from the terminal.
Or within VS Code, especially with the Python extension installed, you'll often see a little play button, usually in the top right corner. Clicking that will typically run your current Python file in an integrated terminal window right inside VS Code.
Ah, the play button. Convenient.
Very. And for more advanced users, you can even configure custom keyboard shortcuts to run your code. Maybe something like Trl plus R or CMD plus R. Lots of options depending on your workflow.
Okay, this is making sense. We write code, we run it. But you mentioned different implementations earlier, like CPython, Jython. What's that about? Isn't Python just Python?
That's a great point and an important distinction. There's Python the language, which is basically the specification, the set of rules and syntax we've been talking about. And then there are Python implementations, which are the actual programs that understand and execute code written according to those rules.
So the language is the blueprint. The implementation is the actual engine built from that blueprint.
Exactly. The default, most common implementation is called CPython. It's written in the C programming language, hence the C. When you download Python from python.org, you're almost certainly getting CPython.
Okay, CPython is the standard. Why are there others then? Like Jython?
Good question. Think of it like having different web browsers, Chrome, Firefox, Safari, that all understand the rules of HTML, or different operating systems. Sometimes you need a specific implementation for a specific reason. Jython, for example, is written in Java. It compiles your Python code down to Java bytecode, which can then run on the Java Virtual Machine, JVM.
Why would you want to do that?
The big advantage is integration. If you have a huge existing Java code base, using Jython lets your Python code interact directly with those Java classes and libraries. Similarly, IronPython is written in C# and runs on the .NET framework, letting you integrate Python with C# code. And then there's PyPy, which is actually an implementation of Python written in Python.
Whoa, Python written in Python.
Yep. PyPy focuses on speed, often running Python code significantly faster than CPython using techniques like just-in-time compilation. But for most beginners, and even many professionals, CPython is the standard and works perfectly fine.
Okay, so CPython compiles our human-readable Python code into what? How does the computer actually run it?
All right, let's trace the execution. When you run your app.py with CPython, it first compiles your source code, the stuff you wrote, into something called Python bytecode.
Bytecode? Is that like machine code?
Not quite. Bytecode is a lower-level, platform-independent representation of your source code. It's not directly executable by your computer's processor like machine code is. Think of it as an intermediate language.
Okay. So source code becomes bytecode. Then what?
That bytecode is then fed into the Python virtual machine, PVM. The PVM is the runtime engine part of CPython. It takes the bytecode, interprets it, and translates it into the actual machine code instructions that your specific computer's processor can understand and execute.
So the PVM is the final translator.
Exactly. And this bytecode plus PVM model is what makes Python portable. You can take your Python bytecode, often saved in .py files, and run it on any platform that has a compatible PVM, similar to how Java uses bytecode in the JVM.
And if you use Jython, for instance?
With Jython, it would compile your Python source code into Java bytecode, which then runs on the Java virtual machine, allowing that seamless Java integration we talked about.
Fascinating. So there's a clear process from writing code to the computer actually doing something. Okay, let's dive into those fundamental building blocks you mentioned earlier. We need to store information. You called them variables.
That's right. Variables are essential. Think of them simply as labels or names you give to specific locations in your computer's memory where you store data.
Like putting a sticky note on a box.
Perfect analogy. So if you write students count equals 1,000, you're telling Python, okay, store the number 1,000 somewhere in memory, and let's put the label students count on that spot. Later, when you use students count in your code, Python knows to go look up the value stored at that location, which is 1,000.
Makes sense. Are there rules for naming them? Can I call a variable first student?
Good question. There are rules and best practices. Variable names generally can't start with a number. They should also be descriptive mitter. Students count is way better than just scheme beyond, right? It makes your code easier to understand later.
Definitely.
The convention in Python following PEP8 is to use lowercase letters and separate words with underscores. So course name, not course name or course name. And another PEP8 tip, put spaces around the equal sign when assigning a value, like students count equals 1,000. Not students count 1,000. It just improves readability.
Lowercase with underscores, descriptive names, spaces around equals. Got it. So what kinds of data can we actually store in these variables? What are the basic types?
Python has several built-in types, but the fundamental primitive types you'll use constantly are numbers, booleans, and strings.
Okay, numbers, like 1,000.
Yeah, 1,000 is an integer, a whole number. You also have floats, which are numbers with decimal points, like 4, 9, and 9. Python also supports complex numbers like 1 plus 2j, which you might use in some scientific or engineering context, but less often in typical web or data analysis tasks.
Integers, floats. Okay, then booleans.
Booleans are your truth values. They can only be true or false. Think yes or no. They're crucial for making decisions in your code. And remember, in Python, they must start with a capital letter. True, false. Case matters here.
True and false, capitals. Got it. And the last one, strings.
Strings are used to represent text data. Any sequence of characters enclosed in quotes, single quotes, or double quotes is a string, like Python programming or Hello World.
Okay, let's unpack strings a bit more. They seem pretty central to, well, almost everything involving text.
They absolutely are.
Yeah.
So we know single or double quotes work. But what if you have text that spans multiple lines, like maybe an email body?
Yeah, how do you handle that?
You could use triple quotes, either 3 double quotes or 3 single quotes. Anything between the triple quotes, including line breaks, becomes part of the string. Very handy. Another super useful built-in function is len. If you pass it a string, like len Python, it tells you the length, how many characters are in it.
So len Python would give me so.
Exactly. When we use a function like len, we say we're calling it, and the thing we put inside the parentheses, Python in this case, is called an argument.
Calling functions, passing arguments. Okay. What else can we do with strings? Can I grab just one letter?
Yep. That's called indexing. Use square brackets after the string variable or the string itself. Python starts counting characters from index 0. So if you have course Python. Then course 0 gives you P.
The first letter is index 0. Okay, what about the last letter?
You could use course 5 in this case, but a cooler way is negative indexing. Course 1 always gives you the last character, course 2 the second to last, and so on.
-1 for the last character. That's useful. Can I get a piece of the string like pith?
Absolutely. That's called slicing. You use square brackets again, but with a colon inside. You specify the start index and the end index, which is exclusive, meaning it goes up to but doesn't include that character. So course 0.4 would give you pith.
Start at 0 up to not including 4. Got it. Any shortcuts?
Yeah. If you omit the start index, like course 4, it assumes you mean start from the beginning. If you omit the end index, like course 1, it assumes go all the way to the end, Python. And course gives you a complete copy of the whole string.
Okay, slicing seems powerful. What if I need special characters inside my string, like a quote mark itself, or maybe a new line?
You use escape characters. They start with a backslash. So to put a double quote inside a double quoted string, you'd use, for a single quote inside single quotes, a literal backslash is dough. And the one you'll use a lot is N, which represents a new line character.
N for new line. Okay. Can I join strings together?
Yes, using the plus operator. It's called string concatenation. So first John and last Doe, then first plus app plus last would give you John Doe.
Simple enough. But is there a better way, especially if I have variables I want to embed?
There is, and it's much preferred nowadays. It's called formatted strings, or S strings for short. You just put the letter F right before the opening quote mark. Then inside the string, you can put variable names or even expressions directly inside curly braces.
How does that look?
So, using our first and last variables, you'd write F high first last. When Python runs this, it automatically replaces first with the value of first John and last with the value of last Doe.
So it becomes, hi John Doe. That looks way cleaner.
It really is. Much more readable than messing with lots of plus signs. The expressions inside the braces are evaluated at runtime, so you can even put calculations in there, like F total cost, price quantity.
Strings. Definitely remembering those. Now, this is where it gets really interesting. You mentioned built-in functions for strings earlier, like actions you can perform on the method.
Exactly, string method. Strings come with a bunch of built-in methods that let you manipulate them. You call them using a .af after the string variable.
Okay, give me some useful ones.
Sure. Upper converts the whole string to uppercase.
Lower
converts it to lowercase. Title capitalizes the first letter of each word.
Does that change the original string?
Great question. No, it doesn't. String methods almost always return a new string with the changes. The original string remains untouched. That's an important concept called immutability for strings in Python.
Okay, so they return a new string. What else?
Strip is super useful. It removes any leading or trailing white space, spaces, tabs, new lines from a string. There's also .lstrip for just the left side, and .rstrip for just the right. .find helps you locate a substring. .course. Find EEA would return the starting index where Doe first appears, which is 2 in Python. If it's not found, it returns doubles 1. Note that it's case sensitive. Replace lets you replace occurrences of one substring with another, like course.replace PJ would return JSON.
Okay, find, replace, strip, .useful. What about just checking if something is in the string?
For that, you don't even need a method. You can use the in operator directly. It returns a Boolean, true or false. So pi in course would return true.
In operator. Simple. Is there an opposite?
Yep. Not in. So Java, not in course would also return true. Very readable.
Brilliant. So we've got a good handle on strings. What about numbers? What useful operations can we do there besides basic plus basic soup?
Okay, numbers. Besides the basics, division is interesting. A single slash always gives you a float, a decimal result, even if the numbers divide evenly. So 10.2 gives 5.0.
5.0, okay.
But if you want integer division, just the whole number part, discarding any remainder, you use a double slash voc. So 10.3 gives 3.
For integer division, what if I want the remainder?
That's the modulus operator.
Yeah.
Percent. So 10% 3 gives 1, because 10 divided by 3 is 3 with a remainder of 1. Very useful for checking even odd numbers, among other things.
Modulus percent for remainder. Got it. Any others?
Exponentiation uses double asterisks. So 10.3 means 10 to the power of 3, which is 1,000. And there are augmented assignment operators. They're just shorthand. Instead of writing x plus 3, you can write x plus x3. Same for area, etc. Just makes the code a bit more concise.
Well, Chef, nice shortcut. Are there useful built-in functions for numbers like there were for strings?
There are a few common ones. Round. Rounds a number to the nearest integer, or to a specified number of decimal places. Abs gives you the absolute value of a number. Makes negative numbers positive. For more advanced math stuff like trigonometric functions, logarithms, square roots, ceiling, floor, you need to import the math module.
Import math. How does that work?
You just write import math at the top of your file. Then you can access functions from that module using dot notation, like math.ceil 4.1, which would give you 5 ceiling rounds up to the nearest integer. There's a ton of functions in the math module. It's worth looking up the Python 3 math module documentation online to see what's available.
Import modules to get more functions. Okay. Now let's connect this back to the real world. How do we get input from the user? Ask them a question.
We use the built-in input function for that. You usually give it a string that acts as a prompt for the user.
Like input, enter your age.
Exactly. So you typically assign the result to a variable, like age, input, enter your age.
Yeah.
Python will display the prompt, wait for the user to type something and press enter, and whatever they typed is then stored in the age variable.
Okay, but here's the catch you mentioned earlier. Input always gives back a string, right?
Always. This is super important. Even if the user types 25, the age variable will hold the string 25, not the number 25.
So if I tried to do age plus 1, I'd get an error.
You would. Python would complain about trying to add a string and an integer. This is where type conversion becomes crucial.
How do I convert it?
Python provides functions to convert between types. Int converts something to an integer, float converts to a floating point number, str converts to a string, and bool converts to a boolean.
So after getting the input, I'd write age and age.
Precisely. Age input, enter your age is common pattern. You get the input string and immediately convert it to an integer, storing the number back in the age variable. Then you can do math with it.
Int, float, stubble, bool.
Got it. Is there a way to check what type of variable currently holds?
Yes, the type function. If you write print, type age, it will tell you the type of the value stored in age, like class int or class swiper. Really helpful for debugging when things aren't behaving as expected.
Good for checking. Now, you mentioned this fascinating Python concept earlier, truthy and falsy values. Can you explain that again? It sounds important.
It is quite important and very Pythonic. So besides the actual Boolean values, true and false, other values in Python can be treated as true or false in situations where a Boolean is expected, like in an if statement.
Okay. Which ones are treated as false?
Those are the falsy values, the number 0, 0, or minimum point 0. An empty string, or an empty collection, like an empty list, which we haven't covered yet, but good to know. And the special value none, which represents the absence of a value. Those are all considered false in a Boolean context.
0, empty string, none are falsy. So everything else is truthy. Pretty much. Any non-zero number, positive or negative, any non-empty string, even 0 or false, any non-empty collection, they all evaluate to true when Python needs a Boolean.
So bool is false, bool 1 is true, bool 5 is true.
Bool is false, but bool hello is true. And interestingly, bool false is also true because it's not an empty string.
Wow. That's subtle but powerful. It could make code much more concise if you know what evaluates to true or false.
Exactly. You often see checks like if user input instead of if user input, relying on the fact that an empty string is falsy.
Okay, that's a fantastic insight into Python's logic. Now, in almost every useful program, you need to make decisions based on conditions like these. How does Python handle conditional logic?
The cornerstone is the if statement. You start with a keyword if, followed by a condition that evaluates to either true or false, then a colon.
The condition. That's where we use those comparison operators like up.
Precisely. Or where truthy, falsy values come into play. So if temperature 30, or if username. Checking if the username string is not empty.
Okay, if condition, then a colon. What comes next?
The code that should run only if the condition is true. And crucially, this code must be indented.
Indentation again? How much?
The standard PEP8 recommendation is 4 spaces. All the lines indented under the if statement belong to that block. Python uses this indentation to define code blocks, unlike other languages that might use curly braces.
So if temperature 30, new line, 4 spaces, print, it's warm?
Perfect. If the temperature is 31 or higher, it prints the message. If it's 30 or lower, it just skips that indented line and continues with any code that's not indented.
What if I have multiple conditions? Like if it's not warm, maybe it's nice.
For that, you use elif, which is short for else if. It lets you check another condition if the previous if or elif was false. So if temperature 30, print, it's warm. Elif temperature 20, dot print, it's nice.
Okay, checks them in order. What if neither is true? A default case.
That's the else keyword. It comes last, also with a colon, and its indented block runs if none of the preceding if or elif conditions were true.
Print, it's called if, elif, else. Clear structure. Is there a shorter way for simple else-false assignments?
Yes. There's something often called the ternary operator. It's a concise way to assign a value based on a condition. The structure is value if true, if condition else value is false.
Can you give an example?
Sure. Instead of
Yeah.
if age 18 else eligible,
else.
message not eligible, you can write it all in one line. Message eligible if age 18 else not eligible.
Yeah.
Reads quite naturally.
Message eligible if age 18 else not eligible.
That is neat. Okay,
Wow.
now what's fascinating is combining conditions. You mentioned logical operators.
Right. We have three main ones. And, or, and not.
And or not. How do they work?
And requires both conditions on either side to be true for the whole expression to be true. If high income and good credit means both must be true, or requires at least one of the conditions to be true. If day Saturday or day Sunday means it's the weekend if either is true. And not simply inverts the Boolean value of whatever follows it, if not is student. Turns true to false and false to true.
Can you combine them? Like check multiple things? Absolutely.
Yeah.
You can build complex conditions. It's often good practice to use parentheses to group conditions for clarity, just like in math. For example, if high income or good credit and not student, this checks if they have either high income or are good credit, and D, they're also not a student.
Parentheses help readability there. Now, you mentioned something really insightful earlier about how Python evaluates these. Short-circuiting.
Yes. This is a key optimization in behavior. When Python evaluates an end expression, if the first part is false, it knows the entire part and expression cannot be true, regardless of the second part. So it stops right there. It short circuits and doesn't even evaluate the second part.
Doesn't even run the second check if the first one fails an and. Okay, what about or?
Similar idea. If the first part of an or expression is true, Python knows the entire or expression must be true, regardless of the second part. So again, it short circuits and doesn't evaluate the second part.
Why is that important? Is it just faster?
Speed is part of it, but it also allows you to write code that depends on the first condition being true before checking the second. For example, if user is not none and user.isadmin, this is safe because if user is none, falsy, but let's say it's checked explicitly. The again and short circuits, and it never tries to access .isadmin on none, which would cause an error.
Ah, so it prevents errors in some cases. Clever. Any other cool comparison tricks?
One very Pythonic feature is chaining comparison operators. Instead of writing if age 18 and age 65, Python lets you chain them much more naturally. If 18 equals age 65.
18, age 65, that reads just like math notation. Very clean.
Exactly. It's one of those little things that makes Python code often very readable.
This is great. We can make decisions, but often we need to do things repeatedly. How do we handle repetition without just copying and pasting code?
That's where loops come in. Python has two main types: for loops and while loops.
Okay, for loops first. When do you use those?
For loops are generally used when you want to repeat something a specific number of times or when you want to iterate over a sequence of items.
Iterate over a sequence, like the letters in a string.
Precisely. Or numbers in a range.
Yeah.
The most common way to loop a set number of times is using the range function.
Yeah.
For number in range 3, we'll execute the indented block 3 times.
What values does number take in range 3?
It will take the value 0, then 1, then 2 range. By default starts at 0 and goes up to, but doesn't include, the number you provide.
Starts at 0, up to, but not including. Can I change the start or the step?
Range 1, 4 will give you 1, 2, 3. And range 1, 10, 2 will start at 1, go up towards 10, but step by 2, giving you 1, 3, 5, 7, 9.
Start, stop, step. Flexible, you said iterate over sequences at range?
Gives numbers.
LS actually gives you what's called an iterable object, something Python knows how to loop over one item at a time.
Yeah.
Strings are also iterable, so you can do for char in Python.print char. This will print P, then Y, then T, H, O, N, each on a new line. Lists and tuples, which are other collection types, are also iterable.
Looping through strings, character by character. Cool. What if I need to stop a loop early? You use the break statement. If Python hits a break inside a loop, it immediately jumps out of the loop entirely and continues with the code after it. Useful if you find what you're looking for or if an error condition occurs.
Break to exit early. Is there an opposite, like something that happens only if the loop finishes normally?
Funny you should ask. Python has a slightly unusual for .else structure. The else block associated with a for loop executes only if the loop completed naturally, without hitting a break.
For else. Interesting. Might be useful for, say, searching the else runs if you didn't find it and break.
Exactly that kind of scenario.
Can you put loops inside other loops?
Yes, that's called nested loops. It's very common. For example, if you wanted to print out coordinates for x in range 3, hashtag @loop 012 for y in range 2, hashtag interloop beers1.print f x.
Okay, how does that run?
The outer loop starts with x equals 0, then the entire inner loop runs for y iterative, then 1 is 1, so it prints 0, 0, 0, 1. Then the outer loop goes to x1, and the inner loop runs again fully, 1, 0, 1, 1. Then x2, inner loop runs, 2, 0, 2, 1. Then loops are done.
Outer loop iterates once, inner loop completes fully for each outer iteration.
Got it. So that's for loops. What about the other kind, while loops?
While loops are used when you want to keep repeating something as long as a certain condition remains true. You don't necessarily know ahead of time how many times it will run.
While condition.
Exactly, while condition. Followed by the indented block. The code inside the block keeps executing over and over as long as the condition evaluates to true before each iteration.
Can you give an example?
Sure. Imagine simulating a simple command prompt that keeps asking for input until the user types quit.command while command.lower, quit.command, input.command.
So it gets input, checks if it's quit, using a lower to ignore case, nice. And if not, it loops back and asks again.
Precisely. The loop continues indefinitely until the condition command.lower becomes false.
What about loops that just run forever?
You can create an infinite loop intentionally using while true. Since true is always true, the condition never becomes false.
Wow, true. Why would you do that? It's common in programs that need to run continuously, like servers or background tasks. But if you write while true, you must have a break statement somewhere inside the loop, triggered by some condition. Otherwise, your program will just get stuck running that loop forever, potentially eating up resources.
Gotta have an exit strategy for while true. Okay, let's try to put some of this together. The source had an exercise. Write a program to display the even numbers between 1 and 10, and also count how many there are. How would we approach that with loops and conditions?
Okay, good exercise. We need to check numbers 1 through 10. A for loop with range seems appropriate.
For number in range, 111, because range stops before the end number.
Perfect. Range 111 gives us 1, 2, 3, up to 10. Inside the loop, for each number, we need to check if it's even.
How do we check for even? The modulus operator.
Exactly. A number is even if it's perfectly divisible by 2, meaning the remainder is 0. So if number per 2 equals 0.
Okay, if number per 2 equals 0, then it's even. What do we do then?
The exercise asks us to display it, so print number. And it also asks us to count them.
So we need a counter variable. Initialize it to 0 before the loop.
Yes. Let's say count equals before the for loop starts. Then inside the if block, only when the number is even, we increment the counter. Count plus 1.
So inside the if, print the number and do count plus 1. What about after the loop finishes?
After the loop is all done, we can print the final count. Maybe using an F string, print. F, we have count even number.
Let's recap. Count even 0 for number in range 111. Inside that, if number per 2 equals 0, 1. Inside that, print number and count plus 1. Then after the loop, print F, we have count even numbers.
That looks like a solid solution. It uses the loop, the condition, the modulus operator, and a counter variable.
Great. Loops and conditions are powerful. Now, as programs get bigger, just having one long script seems like it would get messy fast. How do we organize code better?
That brings us naturally to creating our own functions. This is maybe one of the most important concepts for writing clean, maintainable code.
Why functions? What's the main benefit?
The core idea is reusability and organization. Functions let you package up a block of code that performs a specific task, given a name, and then you can call that name whenever you need to perform that task, instead of repeating the code everywhere. It breaks large programs into smaller, logical, manageable chunks.
Like creating your own custom tools or commands.
Exactly. You define a function using the def keyword, followed by the name you want to give your function. Naming rules are the same as for variables. Lowercase, underscores between words, descriptive.
So def greet oser, maybe.
Perfect example. After the name, you always need parentheses, even if the function doesn't take any input, followed by a colon but. And just like with if and for, the code that belongs inside the function must be indented, 4 spaces.
Def function name, dot colon, then indented code block. How do I actually use the function once I've defined it?
You call it by using its name, followed by parentheses, dot greetuser. When Python hits that line, it jumps to the def greetuser.block, executes the code inside it, and then comes back to where it was called from. Oh, and pp8 recommends putting 2 blank lines after a function definition, just to visually separate it from other code.
2 blank lines after def? Okay. Now, functions often need input, right? You mentioned parameters and arguments earlier. Can you clarify that distinction? It seems crucial.
It is crucial. Parameters are the variables listed inside the parentheses when you define the function. They act as placeholders for the inputs the function expects to receive. For example, def greet. first name, last name. Here, first name and last name are parameters.
Placeholders in the definition. Okay.
Arguments are the actual values you provide to the function when you call it. So in the call greet, Mosh Hamedani, Mosh is the argument for the first name parameter, and Hamedani is the argument for the last name parameter.
Parameters are the slots. Arguments are the things you put in the slots when you use it.
Got it. So what kinds of functions can we build? Do they always just do something like print a message?
That's a great question. Broadly speaking, there are two main types of functions. One, functions that perform a task, like print itself or our greet function example. They do something, maybe have a side effect like displaying output, but they don't necessarily give anything back to the part of the code that called them. Two, functions that calculate and return a value. Think of len or round. They take input, perform a calculation or process, and then send a result back to be used.
How do you send a result back?
Using the return statement. Inside your function, when you want to send a value back, you write return value. For example, def add x, y, return x plus y.
So if I called result eddies 5.3, the value 8 would be returned and stored in the result variable.
Exactly. The return statement immediately exits the function and sends the specified value back to the caller.
Why is returning a value often considered more powerful or reusable? Because the function isn't tied to one specific action, like printing. A function that returns a calculated value, like a formatted name or a sum or some processed data, can have its result used in many different ways. You could print it, yes, but you could also save it to a file, send it over a network, use it in another calculation, assign it to a variable. It's much more flexible.
Decoupling the calculation from the action. Makes sense. What happens if a function doesn't have a return statement? Does it return anything?
Yes, it does. If a function reaches the end of its definition without hitting an explicit return statement, Python automatically makes it return a special value called none.
No. That represents nothing, right?
Exactly, the absence of a value. So if you define def greet name dot print, if I have it on it,
Right.
and then the result greet Bob, it would print hi Bob, but the result variable would hold the value. None. If you tried print greet Bob, you'd see hi Bob followed by none on the next line.
Good to know about the implicit none return. Okay, so functions take arguments. Is there a way to make function calls clearer, especially if there are many arguments?
Yes, using keyword arguments. When you call a function, instead of just relying on the order of arguments, you can explicitly specify which parameter each argument corresponds to, using parameter name value.
Example.
Let's say we have def increment number by return number plus by. Normally you call increment 2 1, but you could also call it using keyword arguments. Increment number 2 by 1, or even change the order. Increment by 1 number 2 makes the call much more self-explanatory.
Increment by 1 number 2. Yeah, that's super clear what each value means. Nice. Can parameters be optional?
Absolutely. You can provide default values for parameters in the function definition. This makes them optional when calling the function. If the caller doesn't provide an argument for that parameter, the default value is used.
How do you define a default value?
Just use an equal sign in the def statement. Def increment number plus by. Here, by has a default value of 1.
So I could call increment 5 and it would assume by is 1, returning 6.
Exactly. And you could still override it by calling increment 5 to get 10. One important rule. Required parameters, those without defaults, must come before optional parameters in the function definition.
Required first, then optional with defaults. Makes sense. Okay, final function superpower. What if I don't know beforehand how many arguments a user might pass to my function? Like maybe I want a function that multiplies any number of numbers together.
Yes. Python handles this elegantly using args. Though the name args is just a convention, the asterisk is the important part.
Args, how does that work?
If you put parameter name, 13 numbers, in your function definition, Python will gather up any extra positional arguments passed during the call and pack them into a tuple assigned to that parameter name.
Pack them into a tuple. What's a tuple?
A tuple is like a list, an ordered collection of items, but it's immutable, meaning you can't change its contents after it's created. So if you define def multiply numbers, and call it like multiply 2, 3, 4, 5, the numbers parameter inside the function will become the tuple 2, 3, 4, 5.
So numbers holds 2, 3, 4, 5. And tuples are iterable, like strings and ranges.
Yes. So you can easily loop through them to make our multiply function work. Def multiply numbers, total, where our tags start with 1 for multiplication, for a number of numbers. Hashtag loop through the tuple, total number, hashtag multiply total by each number, return total, hashtag return the final product.
Whoa. Numbers collects everything, then you loop through the numbers tuple? That's incredibly flexible.
It is. One crucial tip here. with loops inside functions. Make sure your return statement is indented correctly. In this multiply example, the return total should be outside the for loop, aligned with the def statement's main block, so it only returns the final total after the loop has finished processing all the numbers.
Right, indenting the return inside the loop would make it exit after the first number. Okay, args for a variable number of arguments. Powerful stuff. We have truly covered a lot of ground today, really digging deep into Python's core, from understanding why it's so popular and versatile to setting up your environment, the fundamental building blocks like variables, strings, numbers, making decisions with if statements, repeating tasks with loops, and even crafting your own reusable tools with functions. Wow, listeners should now have a really solid foundation.
Absolutely. What's really striking is how Python manages that balance. It's genuinely quite simple for beginners to pick up the basics, yet it scales up to handle incredibly complex tasks in fields like AI, data science, web development. We've really just scratched the surface today, but hopefully provided a strong launchpad.
So what does this all mean for you, the listener? If you've been curious about coding or looking for a language that's both approachable and opens doors to really advanced concepts in high-demand careers, Python seems like a very, very compelling choice.
Hard to argue with its momentum right now.
Definitely. And for your own continued exploration, here's something to mull over. We talked about Python's concept of truthiness and falsiness, how things like empty strings or zero are treated as false. And we talked about short-circuiting in logical operators. How might these ideas of implicit truth, or evaluating things only as much as necessary, apply metaphorically to our own everyday decision-making processes, even outside of code? It's just a thought, a reminder perhaps that sometimes elegant solutions and efficient paths hide behind seemingly simple rules.